Okay guys, so I recorded the last video, and I guess I believe everybody is in agreement that we're going to go with this adjustable voltage regulator, voltage output, as well as 4 individual regulated outputs as well. So that's the first circuit right here, and now we're looking at this. Here is the next circuit, and this is how she's all going to be laid out. A voltage regulator, or adjustable voltage regulator up here, voltmeter, ammeter. I'm not sure if I'm going to use these yet or not. We'll see. I got a nice few S meters there. I don't know if I can convert those to voltmeters or not, but I guess we'll find out. So yeah, we got their adjustable here. We have our 5 volt regulated output here, our 6 volt, our 8 volt, and our 12 volt. So yeah, and each regulator, as you can see, I'm planning on having 2 electrolytics as well as a diode in use with it. Each one of them is going to have the same sort of setup. So yeah. Anyways, let's see if we can't get this project on the go. Hey folks, here's all the mechanical parts that's going to be used in this creation. External regulated adjustable whatever regulated external power supply add-on, whatever you want to call this. Anyways, so we got our fuse holder here. We have our power studs here. That's going to be power input, basically power from the main power supply will feed into here, fused. We have our 5 outputs right here. 1, 2, 3, 4, 5. 5 regulators. 1, 2, 3, 4, 5. We have our common ground, which is going to be this stud. No matter what stud you want to, whatever stud you want to connect to here, that I want to connect to, this point here will always be ground. So to eliminate having to have 300 million of these connections. And I only put all my ground right there. I got my voltage adjustment here. This is for my S meter, or my voltmeter, I guess, adjust. This is my power switch turned on and off, and it has an LED built in. So yeah, all the circuitry in regards to electrolytic capacitors and diodes, all that will be installed on perf boards. So what we got to do here now is start drilling holes. Lots and lots of holes, man. Lots of holes. We gotta make Swiss cheese out of this here case. So this is going to be interesting. There's a lot of drilling. And yeah, the regulators, well, whatever front, this front, that front, don't matter. But most of these studs here, controls everything will be on front. These 2 contraptions here will be on the back. And I'm not sure if I'm going to have an ammeter or voltmeter yet. I'm not sure, because I may not have the space for it. And if I don't have the space, then basically from here over will be eliminated. But I'm going to try to use these if I can. But yeah, we'll see how it goes. Anyways, let's start drilling some holes here, and yeah, see what we can get ourselves into. Well folks, here we go. I went ahead and built the add-on voltage supply. Again, takes voltage off of regular power supply, and I can adjust voltage down to different values depending on the circuits that I want to build. So right now what I have here for regulators, use my pin here, the plastic. I got a 5 volt regulator here, 6 volt regulator here, 8 volt regulator here, 12 volt regulator here, and the LM317 adjustable regulator right there. So right here we have, this side here is power input. Got two studs here on the back for power, fuse. I got LEDs put back here. Basically what's the reason of these? I have a red LED, basically lets me know that the circuit is, that I have voltage going to the switch. Just power supplied back here is what the red one's for. Then when I turn the unit on, the green LED lights up, and so does the orange. And the orange one, you can't really see it because there's so much brightness here, but let's see. I can adjust the voltage down and turn it off. Just gives me an indicator that the adjustable voltage regulator is working. So we have adjustment right here, which adjusts the voltage to the LM317 right here. We have I have 1N4001 diodes across each regulator. I have a big old power switch. Again, common ground, individual power studs. We have a bunch of electrolytic capacitors held in here with two-way tape, and it's quite stiff holding it there, so I don't think they're going to go anywhere. So what I have here, I have 4 1000 UF 25 volt caps, these first 4. Then I have a 1000 UF 35 volt. This one goes to the output of the LM317. The other 4 are just attached to the other regulators. But yeah, so I'm just going to show the voltage adjustment on the voltage regulator, on the variable. I'm not getting as much voltage out of it as I thought I would, but it does drop it down to nothing. And then I can vary it all the way up to 7.5. Now the resistor I'm using here is a 10K variable and a 220 ohm resistor. I might have to play around maybe with that 220, see if I can get a little bit more voltage out of this 3M LM317. I was hoping to get pretty close to supply voltage from the LM317, or at least close to 12 anyway, 12 volts. Go from 0 to 12, but as you can see, the most I'm getting is 7.574 volts maximum. So I'm going to mess around with this circuit, see if I can get a little bit more out of it. But as you can see, I've done I spent the last 4 hours, I guess, building this thing. And I have to say, I think it came out very well for itself. So let's see if I can't show you the yellow LED a bit better. See if I can wait till see it. Can't really see it. I'll turn the light off on the camera. That might be messing with this a little bit. There you go, just see it there, pulsating, see there? This is a voltage indicator letting me know that the M317 is working. But anyway, there you have it. Anyways, thanks for all the input from a couple of people out there for how I was going to build this thing. But I went ahead anyways and built it anyways. And this here is pretty much the circuit that I used, minus this. Meters I never used, but everything else here is pretty much the same. The electrolytic capacitor on the input of the regulators, I didn't install them, but the electrolytics are hooked up on the output of each regulator for a total of 5. But anyways, so question for anybody out there now, since we know this is working, is it possible, you think, to get a little more extra voltage out of the LM317? Is it possible to get more than 7.5 volts out of her? I'm sure there is, but I'll leave it up to you guys. What do you guys think? Think it's possible to get some more voltage out of that LM317? Because right now, that's as much output as it will put out in regards to voltage. Anyways, hope you enjoyed the video, folks. Again, if you have any more suggestions for this, let me know in the comments below. Anyway, guys, all the best, and we are out of here. Rhino 63 out.